So we talked last Friday and this week about different kinds of power distribution. We talked about the power factor. Does anybody remember what is the power factor? Peak voltage and effective voltage. Remember when we do the sinusoidal wave for AC current? What was that? Peak voltage. What is here?
What we're actually going to use.
90 degrees. Or
Yes, actually this is the effective voltage. This is what we're going to use, right? We said, what is the angle here?
0.
No, 0.
90.
90. And this one?
270.
No,
180.
no.
360.
Effective voltage?
45.
Huh?
75.
45.
45. Thank you. 45 degrees. And the sine of 45 is 0.707. We said the sine of 90 is 1. And we said, again, we get the peak voltage, but we can't use the peak voltage, we have to use the effective voltage. And so the power factor is the ratio between what you actually measure when it comes to voltage and what is calculated. This is the calculation. We'll go with sine 45 for whatever peak voltage, that's the calculation. You don't need to get your calculated power. You're gonna get the effective, which actually you go and you measure the voltage, and that's going to be the power factor. The power factor does change from one power company to another. Good. And also it's changed based on the power distribution and the converting transformer. However, what you need to understand is there's power, effective power, and calculated power. Distribution. So we said at the beginning of the 19th century, DC was the dominant power, and every house had a DC generator nearby. And the problem was, direct current is not, DC is not good for power transmission. It will fade over time, it doesn't go a long distance. What voltage do we have in the car? DC or AC? DC. Why? And the car is very small. It's going to go around the car. We can't have the same thing with transmission. What voltage goes into photovoltaic cells? AC or DC? Photovoltaic cells, solar cells? DC. As Tim said last class, why is it DC? It's a reaction. It's chemical. It's going to give you constant voltage for a long time. Same as batteries. Most batteries are DC. You agree? Yep. So transmission for a long distance is impossible without using generators to boost power. Every station you're gonna send, for example, 480 volts. Next station will be 300, and so on and so forth. So it was not very effective. We cannot raise and lower the voltage. It's going to be the same all along the line of transmission, and it required large transmission equipment. So that was not very effective until Tesla came and thought of the idea of, okay, what if we use waves and use sinusoidal waves to send AC current? And he started with his station in upstate New York, in Niagara Falls, so that's why you have a museum there for Tesla and his AC current. So, what do we need to know? The power plant will send big sum of voltage from 120,000 volts to 220,000 volts. That's a lot of voltage. Usually, power plant is not in a residential area, it's outside the city. Why? It's a lot of voltage. They will generate a lot of EMF, and they don't want it to be in a residential area. It will go all the way to a substation. That's probably in your neighborhood. You're gonna have a substation. Substation usually will have 4,800 volts. That's still a lot. Substations usually are caged. You're not allowed to access it. The power company have to get permits to go there and work work with the substation. Then you go to, let's say, this is Springfield substation. You have two types of customers or consumers: commercial and residential. So we said, what is the difference? What is the voltage you get in your house? You go to your basement, you're gonna see this. What is the power coming to your control panel? 240. 240, 220. Which leg is this? Each leg is how much? 120. So this is a 120 transform circuit breaker, and this is the 220. So every house has 220. That's it. How many phase? One phase. If you get more than one phase, something is wrong. And because a commercial building has been converted to residential, pay attention to that. Every panel, it goes like this. 2 hot legs and 1 neutral. The hot legs are 110 each, and this is how we take the power. 240, 120, residential consumers. For commercial, it gets a little bit more intricate. We have different varieties. Why? Why do we want to have 2 phase? More power. We gotta run big motors, right? More power, more efficiency. Why can't we, if we have more power, why can't we have more power for residential? What do you think is the disadvantage of having more power and more phase? Money, costs a lot of money. They charge you differently for commercial. You don't pay the same thing for commercial as we paid for residential. And we try to make equipment that will run with 1 phase and 120 voltage. So, what is your job? You want to know what is there? When you look at the panel, you want to be able to recognize what am I looking at. If you go to a residential building, it has different or funny looking control panel, and you have to wire your boiler. You want to recognize what it looks like and make sure it's familiar. If it's not, double check. Are you allowed to work on the control panel? Nope. Only a certified electrician. You're gonna call somebody and verify. Okay, so 240 volt single phase, 60 hertz. What would that look like? I see it on equipment. You'll see this in the AC. That's basically voltage. 1 phase, 60 hertz. Huh? It could be 240, but if I see 120, it's going to be 120. So if we look here, we have single phase alternating current. Exists in most residences. Domestic appliances, they use 120. What equipment use 100? What about boiler? That's 120. What do you think will use 240?
Air conditioner.
Dryers?
Washing machine.
Ovens?
Washing machines.
No.
No.
The dryer only. Yeah. How would you know? If it's in doubt.
Look at the plug.
Yeah. Look at the plug. The plug will look funky. And each phase and each power distributor has a different plug. In the US, they have foolproof plugs. Even 220.
on the tag.
Yeah. But make sure the plug matches, and sometimes you invite an electrician to come rewire your dryer, and he found a different plug, and he's the only one who was responsible to go and change the plug shape to different shape. And we went through the lab and we saw all the different shapes of plugs. All the structures, that's something you're gonna face a lot, especially with your mess. You're gonna have some old houses. You'll see wires insulated with fabric. That is common. You'll see wires made out of aluminum. And why did they use aluminum? Huh?
Cheap.
Cheaper. What else?
Paper insulation.
Tissue paper insulation.
Season
Yeah, there was copper shortage during World War II, and some manufacturers switched from copper to aluminum. And probably you'll see wires installed in the 50s and 60s being made of aluminum. What do you do if you see these wires? Change them. You can. Probably customers not gonna like that, but you gotta change them. So home structure, still possible to find single phase 2-wire system. This is the most common thing you'll see in the industry. If you feel in doubt and feel the wiring is not sound enough to handle your equipment, you might ask the the owner to change the wires because it's unsafe. How do you know if the installation is safe? The wire usually is not going to have any problems. The installation could be crispy, falling apart, some parts are exposed. If you see any part exposed, definitely you have to change the wires. This is the line voltage, as you said, one neutral and one hot. Where do you put, what is this? Now what is this box?
Oh, no,
Fuse or a circuit breaker? Do you put a fuse in the neutral? No. No? You always put it in the power source. If you go and see a small power switch or circuit breaker, it will look like these things. So for most residential equipment, you have your own cutoff switch. And if you see a fuse, means that they're all powered lines. So I see 3 fuses here. So what do you think this is? You have 3 fuses, mean 3 hot lines, 3 phase. Thank you. And it's part, it could be 3 phase and it could be also just 420, 480, 460. So fuse means hot line. So what do you think that is? That's exactly what you're seeing over here. That's your power panel. 2 hot lines and 1 neutral. And this is how it's wired from the transformer in your neighborhood, your district. 4,080 and 800 volts. The primary is coming to the substation, and this is how we get a transformer into the house. How does a transformer work?
Coil in a metal.
What is that called? Induction. And we had a wireless charger here that has induction in it. So using the induction, the right winding, we can have a transformer here that give you 240. 3-phase voltage system. Do we have 3-phase here in the shop?
Yeah.
We have 3-phase. We have 240 and we have 480. It's a lot. It's very common for industrial application because what Felipe said, it has more power. I need more power. I need more effective motors, and it has 3 hot legs of power. This is 3 hot legs of power. Each one of them is hot. Do we need a neutral?
No.
We do not need a neutral, but there must be a ground somewhere. There's always a ground. 1 ground in the distribution equipment and 1 in the equipment. You never want to operate without ground. Ground voltage is important. What if there is no ground? If anything goes wrong, you got 3 phase, yeah, it's going to be dangerous. Very versatile.
Once you have a fuse,
Huh?
for that, once you have a fuse for that reason,
The fuse working with only 1 line probably. If you have a lot of voltage, it might arc even through the fuse, so you need to have a ground. What do they mean by more versatile? Question.
Yeah, in the last slide you had 2 100s going.
Yeah.
But you said that could be 480, so is each one 240?
So if this link 120, we have between this and this 120. If we have those 2 together, we have 240. I can get 120 from the neutral without this one. So this is 110, 120, 120, and 240. This is good for you to understand in case it's your own house and you want to wire something. You can do it yourself with confidence. This is paying, I don't know how much for the electrician to come to your house and do it. But if you trust yourself,
I seen a bill with someone that did a circuit like that.
yeah.
It's like 700.
Hour.
And and to be honest, they're worth every penny. People, they went through 5,000 hours of training. They are worth it. And you don't want to mess up, be the cause of a fire. And again, if you work in somebody's house, the insurance would love to see the certificate of everybody who installed something. There's a guy who wired his entire house, and he wanted to get it inspected. They said, "Who wired the house?" I did. Well, then, until they get an electrician to come and rework and give you approval, you can't get his house certified. And is the electrician gonna come and look at your work? No. No, I'm sorry, it's not my work. I'm not gonna go look at everything, I'm not gonna wire the whole thing, so we don't want to do that. Same with you. Now you're gonna work on ACs, you're going to work on boilers. Would you want to go and do somebody's half-time job? No. I do things differently, I'm gonna charge you. And rightfully so, you went to school here, you sat here, you listened to me and watched torture. You deserve to get paid, don't you? Or somebody was like, didn't do anything, I said, yeah, I'm just gonna go look at YouTube and wire it. No, it's not the same. So, you have more knowledge, whether you know or not, you're gaining more knowledge about small little things that adds up at some point. So, people gotta eat, you know? Don't skip people.
You all gotta-
And also don't overstep and over turf, man. Let the electrician do his thing, let the plumber do his thing. You're in construction, you understand? It's not really, not fair. So, three-phase is more versatile. Advantages require no special starting apparatus. If we talk about motors, if you see a motor with no capacitor, it's three-phase. It runs right away because we have three forces within 120 degrees. You will see also three motors with no capacitors that runs. They have something called shading pole. We'll talk about that a lot in the next chapter. Versatile in running electric motors, very smooth. Disadvantage is the higher cost of the panel and distribution equipment. Of course, the power company do not let you buy the panel that were rented for you, and they charge differently, and kilowatt is different because you are commercial. If you're using this equipment, you're supposed to be using it for business. It should come out of your business expenses, so it's going to be expensive. So this is the only disadvantage of the cost. The equipment is going to be higher in cost, and charges for the electricity is higher. 240 three-phase. Yeah, we can get 240 three-phase 60 Hz delta system. It's called delta system because it looks like a triangle. So from a three-phase line, you can have a lot of variety. So using structures requiring a large supply of motor and other three-phase equipment. 4 wires, so we can change 3 hot legs and neutral. I'll show you what it looks like. I don't expect you to remember this completely, but at least you know what it looks like, and you know there are different types of power for industrial. So they're not all the same, they're not all different, but at least you have your book with you at some point. You're gonna look, you can ask, what kind of power system do we have, how many phases, and what is the voltage. This is the delta system, 3 hot legs, 120, 120, 120, and probably neutral. Where's the neutral? Somewhere here is the neutral. But we have 3 hot legs, and between them is 240, and it's 3-phase. The wiring and the intricacies of that in science is not something that you should concern yourself with, but you have to know that the 3, what do you have to know about the delta system? It looks like a triangle, 3 hot legs, and a neutral. Can you remember that?
Where's the 208 come from?
Huh?
The 208.
Differential between them? This is what it looks like with some equipment. I just want to make sense out of it. But again, it looks like a delta. This is the wiring, leg 1, leg 2, leg 3, they're all 110. And delta system, I'll give you 3-phase.
Where's the neutral?
You have a ground, this is the neutral. L1, L2, and L3. Very easy, interesting. 208, 3-phase, 60 Hz Y system. What does it look like a Y? It looks like a Y. You'll see how it looks like. Structure quite a large number of 120 volt circuits. So probably you're gonna have 3-phase 2-volt and a big structure, like a big huge building, like building 17. Most huge buildings have those kind of structures. Again, you can mix and match. You're gonna have 120 one phase, but I'm gonna supply you with 204 and 60 Hz 3-phase Y system, and you distribute that. We have that in the shop here. If you look at those transformers, they have the Y system. That's what it looks like. Looks like a Y, neutral, coming out of here, and leg 1, 2, and 3, 120. Between those two is 2.8 and 2.8. It looks like a Y, 3-phase, 3 hot legs, and neutral. Both the Y system and delta system. Do I need to remember this? No. Am I going to ask you about it? No. But you know it does exist, and it's in commercial buildings. That's what it looks like. We have 3-phase riding on it. Delta system primary, Y secondary, looks the opposite of the filter system. Too much calculation, I don't want you to remember any of that, but at least you know the main idea. RMS, that's effective voltage, calculated, times the max, looks familiar. You need a power factor to tell you what am I getting out of measuring this current and voltage with the power. It's very intricate, but again, that's something for someone who's going to work on power generation. Y system again. Higher voltage systems, they're becoming more popular. Industrial structures, commercials. People are asking for more higher power now because they have different equipment, and also because it's versatile. I can get just 3-phase 120 and just get whatever I need out. 120, one phase, 3-phase, and that's what we have here. We have multi-phase power. We have a lathe machine. We have a milling machine. They all require 3-phase. So you can get single phase, and also 3-phase, and different amounts. And up to now, the maximum voltage we got is 480. Can you measure 480 with your multimeter?
Depends.
600.
You got it.
600, yeah.
Yeah? Yeah. So you can go and measure that. It's not gonna kill you. You have a multimeter go up to 600 volts. There's nothing more than 480. Huh?
That's the 2 fingers, so
If you want to do that. Natural switch. Advantages, a little difference in switches, relays, and electrical. When you go to 3-phase and single phase, it's completely different. Common high voltage system implementation, the disadvantage is the cost and how complicated it is to put in the system. Again, 480, 3 legs, a Y system, more schematics for that. And I think for our intended and purposes, we do not need to know much as long as you know the different phases and different hot legs, and you can measure that with your multimeter. Alternator, delta system, effective voltage, frequency, peak voltage, phase, power factor. You remember any of these? I'm going to ask you some of these in the quiz, since you know what they mean.
What's an alternator?
Alternator is a device that generates electricity. It's a motor that will propel and it will give you alternating current. You can say something in your car that generates electricity, which is the battery. Huh?
in all the cars, motorcycles, everything.
Yeah.
Delta system.
Sine wave, single phase, 3-phase, Y system. You know this. And that's basically the summary of chapter 7. We'll go through the questions on Monday, at the end of the book, and hopefully you remember some of them. So what do we take out of this? There's peak voltage, there's effective voltage, power distribution. What is the power at your substation?
400.
4,800.
800.
Power coming to your house? 240 or 220. And that's going to be 2 hot legs and neutral. That's what you need to know. If you know how to work the panel, you should be fine. Go ahead.
Sine wave is the 45, right?
No, sine wave, this snake thing is sine wave.
Oh, okay.
Okay, we're good.